Good evening, everyone. Let me begin today's video. What do we have? I hope my screen is shared. Okay, yeah, right. So for today's video, once again, we are looking about the understanding the radius of gyration. This video or this problem might be a little bit higher for high school students. If you do not know integration, then I think probably you might face a problem not understanding it. Okay, so it's once again I can say that you need to learn integration so that you can understand this video. Otherwise, it's fine. Okay, especially this is a wait just a moment. Okay, this is a problem which one of my students did, and he was studying for his JE, and while he did this, he made a mistake like this. Okay, and in fact, while we looked at it first time, even we also thought that this is right. But second time when I looked at it, I realized what was the problem. Okay, I can say a brilliant misconception. Okay, so this is something like it's a derivation present in several of the textbooks. But the way how he did it, so for one moment, even I got lost. Let us see what made him to think like this. And this was really an eye opener for me to say that, okay, so these kinds of misconceptions can also arise. Let us look into it. So find the moment of inertia of a hollow cylinder with an axis passing through the vertical axis of the cylinder. So this is my vertical axis. This is my vertical axis. So we need to find out what is the moment of inertia of this. So towards it, what he had done is he has done something like this. He took the surface density of the cylinder. Surface density is mass by area. He took the total mass of the cylinder divided by the area. What is the area? Area is nothing but, see, he thought, of course, it's real also. He considered that the cylinder is now made out of several rings. This is one ring. This is the other ring. Okay. Like this, it is now made out of several rings. Now I can stack one ring above the other ring. I keep on adding up rings like this. Okay. Each of width delta x. Delta x or dx, whatever you call. Okay. Let me call this dx. And then when I keep on adding like this, then I can reach it to a height h, and thereby it becomes a hollow cylinder. That's what he did. So as a result of it, the area of this is nothing but circumference multiplied by the height. Okay, the total height is h over here, 2 pi r is nothing but the area. So the density, surface density is equal to so much. Now based on this, if you want to find the small mass, what is the small mass? The mass of this ring, the mass of this one ring, if I want to find out. This mass of this ring is nothing but lambda into 2 pi r into dx. How do I get this? Lambda, what is lambda? This is surface density. See, so usually, okay, this is mass by area, right? This is mass divided by area over here. So if I multiply this by area, I will get the mass over here. Now, which mass is this? The mass of the ring over here. Okay, so which is nothing but, so 2 pi r. What is 2 pi r? The circumference multiplied by the delta x. What is delta x? Delta x is the height of the ring. Okay, so as a result of it, I give this dm. What is dm now? Dm is the mass of the ring of thickness dx. Wonderful. It had good. Yes, done it well. Okay, until here, nothing, no problem at all. Then moment of inertia is given by the formula integral of dm into x squared. So then what we do is we write integral of the lambda into what is dm? We already got the value of dm. We substitute it over here, and we substituted all this, and finally we integrated this. Lambda, I just brought it outside. It's nothing but m by 2 pi r h, because lambda is a constant. I brought it outside. Then multiplied by 2 pi r, and then I integrated from 0 to h x squared dx, which I got this as mh squared by 3. Okay, initially I thought, wow, this right. But for a moment I got lost. And then I thought, how can it be mh squared by 3? Because we know that the moment of inertia of a ring, of a moment of inertia of a hollow cylinder is nothing but mr square. So what made him to think like this? Then I gave it to my friend, asked him, okay, what is the mistake here? Actual correct value should be this one, but he is getting something like this. He is getting this as a function of h, but it should be as a function of this, and so on. Then two of my friends looked into it. Even they didn't get it. Then we pondered it a little bit. Okay, and then when we looked into it, we got an idea. The idea here is that the misconception here is that, see, it is true until here. Okay, integral of dm into x square. Now, what is this x square? X square is nothing but the distance of each mass from the axis. Okay, which means that I should consider this mass. I should consider this mass. I should consider this mass like this. Okay, I should consider each of these masses. So this is what it is. So as a result of this, now what is the distance of this mass from the center? It is this is nothing but r over here. Now when I talk about x here, when he talks about x over here, x is referring to this distance. This distance. Starting from x equal to 0 to x equal to height, which means he's talking about the length of the cylinder, which is incorrect. Okay, this part goes wrong. This part goes wrong. When you say dm into x square, it is not, this distance x is not about the thickness of the disk over here, but instead, okay, this distance should have been the radius over here. I hope you understand this. Okay, very important concept while we do the radius of gyration. Okay, so if you understand this, I think many of the problems related to moment of inertia determination can be easily got. Okay, so therefore, this x over here is nothing but r, but he considered the x as a variable. Actually speaking, x is not a variable, x is a constant. Why constant? Because x equal to r here. Okay, so the actual correct solution, the correct solution should have been, what should be the correct solution? You should have got, this is my cylinder, then this is the axis, then I should have written moment of inertia is equal to integral of dm into r square. I should have replaced this one. Now r is a constant. I will remove this r square into integral of dm. Now what is dm? Mass of the ring here, mass of the ring here, mass of the ring here, and so on. Right? Okay. So now I will consider one ring. Okay. And then if I add up all these masses, then what I will get? I will get in terms of mass m here. So if I integrate, when I say integration of dm, what do you mean by it? Which means integration can be replaced by summation also. dm. What do you mean by it? Which means that you are going to add up all the masses, not only due to one ring, but due to all the masses present in all the rings over here, which will thus give me r square into capital M. It means I'm adding up all the masses, considering all the masses here, which would be m into r square. Thus, m r square should have been the answer for this. That's what we have got here. See, a very small mistake by not understanding which distance should we take here. Okay, made all this trouble. Okay, though appears to be very much correct. That's what happens. Misconception is something like it appears to be correct, but it's incorrect. Why does it happen? Because of a slight modification. We make a small mistake somewhere and we understand this in a different way. And as a result of it, we get this. Most of the students will not commit this. The reason is because it's a derivation. Okay, but there are some students who understand the core concept. Okay, but somewhere they make a small mistake and they make this mistake. Okay, so many of them do by heart this. Okay, they by heart this one. Say, a moment of inertia of hollow cylinder, I can do it easily. Okay, I've never seen this mistake done by many people. But there was one student with me who always want to explore. You know, the advantage of exploration is something like this. Okay, you do a problem, you commit a mistake, you learn why did you commit the mistake. Very, very important. That's where the entire series of misconceptions in physics I have made it. I've done several mistakes like this. Okay, but after I look into what was the problem, where did my concept go wrong, why did I make this mistake? That is very important. You need to scrutinize, okay, why you are making a mistake. Until and unless you do not scrutinize and you just look at the answer, you got the answer, it's fine. You did not get the answer, somebody gave you the answer, it's fine. Don't do it. If you do not get an answer, that means there's very much to explore. So look into it. Thank you, friends, for watching this video. If you really like this, just a moment. Okay. So if you really like this video, do share and subscribe to my channel for more updates. Thank you. Thank you very much. Let us see tomorrow more on the other rotation parts. Thank you.